Expecting you put it where the sun is, it would loosen up to the circle of Jupiter. A beast, absolutely flimsy and going to detonate. They are among the most noticeable effects of radio energy in the whole universe, conveying more energy than a billion suns. Bug-Ju, or surprising Crawley-Ju, is a red Goliath star. Expecting you put it where the sun is, it would interface with the circle of Jupiter. Gigantic, totally conflicting, and additionally going to detonate. At the point when we contemplate stars, we no longer just envision immaterial, glittering things in the night sky. Essentially, this is the manner by which we see them from down here on the planet. Yet, stars are something else entirely. As a matter of fact, perhaps one of the most noticeable stars, Betelgeuse, is fundamentally more massive than our sun for a long time. In any case, this star has baffled specialists. In all honesty, something more disturbing has been going on with Bug-Ju, making examiners and other very accomplished people phenomenally concerned. Join us in this video as we explore the great new information about Bug-Ju, its coming destruction, precisely true to form by the James Webb Space Telescope, and how this new progression will influence our universe and our lives here on Earth. As figured out by physicist Michio Kaku, Bug-Ju is a tremendous wonder, a giant star that has entranced cosmologists for such a long time. A Greek space master named Antonius was the first to track it down. This star is so tremendous that it can be seen in the evening sky from Earth, especially during winter. If you're into cosmology, you've unquestionably seen or heard about the star. The becoming flushed orange star implies the upper left shoulder of the Orion's glorious body. So, you see, this star is outdated and, up to this point, perhaps one of the most superb stars in the night sky. However, one thing about startlingly pretty much nothing, Animal Juice's brilliance is that it doesn't remain trustworthy. Rather, it varies. This change is one of the great properties of the star, but it isn't the only one. We should investigate some of Bug-Ju's particular properties. The greater part of the stars you track down in the evening sky are far from Earth. The closest star is 4.2 light-years from Earth. If you excuse how the term light-years gives a sense of distance, picture it this way. Consider moving at the speed of light for an entire year. It's been demonstrated that light can cover a distance of 186,000 miles per second. Consequently, the distance light can cover in a year is basically equivalent to 1 light-year. If you do the math, you'll have billions of miles. So, when we say the nearest star is 4.2 light-years away, it means it is, in any case, billions of miles from Earth. Some stars are farther, and Bug-Ju is one of them. Bug-Ju is found around 600 light-years from Earth. So, expecting that you somehow wind up going to it at the speed of light, it would still require 600 years. We can't move that quickly. Indeed, even our speediest space rockets can't. Nevertheless, this star can shimmer so brilliantly in our sky. If you're thinking about how Bug-Ju can be so incredible, no matter the distance, it's a consequence of its unique attributes, like size and quality. Bug-Ju is on various occasions more colossal than our sun. Its range is perceived to be generally that of the sun. Unfortunately, it appears as a plate in space, while using current telescopes, while different stars appear as almost nothing spots of light. This is acknowledged to be an effect of the responses at the outer layers of its air. With respect to mass, Bug-Ju weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass used by space scientists. One solar mass is approximately 2 times 10 to the power of 30 kilograms. Experts can't pick the precise mass of Bug-Ju since there are no other planetary bodies orbiting around it to examine, and clearly, we can't measure it directly from here on Earth. Nonetheless, it makes Bug-Ju many times heavier than our sun. The splendor of Bug-Ju goes from size, in addition to 0 to in addition to 1.6. In more irrefutable terms, Bug-Ju is customarily more astounding than our sun. No incredible treat, it was nicknamed a red Goliath. In any event, the nature of Bug-Ju doesn't remain steady. It varies. This change is because of its throbs, or in other words, Bug-Ju grows and contracts. When it broadens, it gets more dazzling. Right when it contracts, it lessens. This cycle can persist for 10 to 100 days, or even much longer. A smart property of Bug-Ju is that its surface is canvassed in dull, appealing spots. The appealing field here is undeniably more grounded than at the typical surface. At any rate, the downside is that these strong alluring spots slow down the movement of hot gas to the star's external surface, making the star cooler in these regions. The truth that Betelgeuse has so many of these spots, as compared to our Sun, makes sense of why it is cooler than our Sun, notwithstanding its size and brilliance. The Sun also has its own faint alluring spots, but those on Betelgeuse are much larger and far more numerous. To give you an idea, the spots on Betelgeuse can be twice as wide as Earth. Betelgeuse parades an appealing field that is a huge number of times more grounded than that of the Sun. This field is the explanation that when seen through a telescope, the gases on the outer layer of Betelgeuse appear to spin around or curve. Betelgeuse has a surface temperature of around 3,500 K. This low temperature contributes to the low energy released by the star and its weak red color. Surprising little animal, Betelgeuse is a red star, but it wasn't always red. It was yellowish, something like quite a while ago, like our Sun. Over an extended time, the variety started changing to orange, red, and then, around 1 million years ago, it slowly began changing into the red star we know today. This fact has led researchers to believe that the star is evolving. Betelgeuse produces as much as a few times more energy than the Sun. It would have been a rival to Earth's Sun if it weren't so far away. The fact that Betelgeuse, which is 600 light-years away, can still be seen and recognized with the naked eye around nighttime is incredibly striking. Our Sun is basically 8.3 light-minutes from Earth. That is the reason it's so strong. If Betelgeuse were only a little closer, we would also be able to see it during the daytime. However, if it somehow figured out how to replace the Sun, it would consume or displace the Earth and the other 4 planets near it. As a result of its enormous size, even if it were to match the Sun in size, it would still produce more radiation. Betelgeuse, otherwise called Betelgeuse, is a very massive star located in the star cluster Orion, about 600 light-years from Earth. Its gigantic size is possibly one of its most striking parts. It is customarily much larger than our Sun regarding its size and could easily incorporate the circle of Jupiter if placed at the center of our solar system. This fantastic size allows Betelgeuse to appear as a circle rather than a point of light when seen through telescopes, unlike most stars. Various stars, in spite of their colossal size, have unique characteristics. However, Betelgeuse isn't the most massive star. Its mass ranges from around 12 to multiple times that of the Sun. This assortment in mass estimates is due to the challenges in precisely assessing the mass of stars that lack companion stars or other objects to provide gravitational reference points. In fact, even at its lower estimated mass, Betelgeuse remains a giant celestial body. The brilliance of Betelgeuse is another key characteristic. It varies consistently over time, with its brightness going from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude 1 star. At its brightest, Betelgeuse can be several times more luminous than our Sun. This change is attributed to its throbbing, irregular expansions and contractions caused by internal cycles within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These throbs can last for long periods, contributing to its dynamic appearance in the evening sky. Betelgeuse's surface temperature is somewhat low for such a massive star, measuring around 3,500 Kelvin. This gives it a distinct red tone, typical of red giant stars approaching the end of their life cycles. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has exhausted the hydrogen fuel in its core and has begun synthesizing heavier elements. This fusion process generates energy and causes the star to expand outward. The star's environment is rich in complex physical phenomena, showing dark magnetic spots on its surface where the magnetic field is stronger than the surrounding areas. These spots inhibit the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains a spectacular, bright star. However, it will eventually meet its end in a magnificent, catastrophic explosion. Betelgeuse is a massive star nearing the end of its life, and its possible fate will be an emotional one. When it runs out of fuel, it will go through a final fusion process, turning heavier elements like helium and carbon. This will cause the star to expand to potentially much larger sizes, possibly becoming one of the biggest stars in the night sky before it dies in a massive explosion, a powerful event marking the death of a massive star. The force of a supernova is strong enough to destroy an entire solar system. This phenomenon could even send shockwaves through space, and it's possible that Betelgeuse will experience such a dramatic end soon. While this fate is not inevitable, it is something scientists are closely studying to better understand the fate of stars and the evolution of the universe. As Betelgeuse approaches the end of its celestial life, astronomers are closely monitoring its behavior. The star is expected to eventually go supernova, a catastrophic event that will result in the release of its outer layers into space, leaving behind a dense core. This core could become a neutron star or collapse further into a black hole, depending on its mass. A supernova is a devastating event in a star's life cycle, marking the final stages of its evolution. Betelgeuse's potential supernova could be visible from Earth without the aid of a telescope, given its immense brilliance and relative proximity. This explosion would release enormous amounts of energy, creating heavy elements like iron and nickel, which are crucial for the formation of planets and other celestial bodies. These elements would be spread throughout the universe, enriching the interstellar medium and contributing to the formation of future generations of stars and planets. Interestingly, scientists have detected unusual changes in Betelgeuse's brightness recently, leading to speculation that the star could be approaching the brink of a supernova. However, despite these fluctuations, it is difficult to predict exactly when the star will explode. Some researchers have suggested that Betelgeuse could go supernova within the next 100,000 years, a short time in the life of the universe, but still far enough in the future to make precise predictions challenging. The James Webb Space Telescope, JWST, has provided new insights into the star's behavior. Its infrared capabilities allow scientists to study the star's outer layers and magnetic fields in exceptional detail. JWST discoveries have confirmed the star's ongoing changes, including its fluctuating brightness and potential instability. These observations provide critical data about the processes leading to a star's death, offering a better understanding of stellar evolution. Betelgeuse's demise will have wide implications for the universe. The shockwave from the supernova could trigger the formation of new stars in the surrounding region, supporting the cycle of stellar birth and death. Additionally, the elements created by the explosion will spread through space, contributing to the building blocks of new planetary systems. In the grand scheme of astronomical evolution, Betelgeuse's death will not only mark the end of one of the largest stars we can observe, but also pave the way for the next generation of celestial objects. Although we may not be around to witness the star's final moments, the study of Betelgeuse provides valuable insights into the life cycles of stars and the dynamic nature of the universe. The research conducted on this star helps astronomers better understand the processes that govern stellar birth, life, and death, and it offers a glimpse into the future fate of other stars with similar characteristics. In the future, researchers hope to continue studying Betelgeuse with the help of advanced technologies and space observatories. The data collected from the star will continue to shape our understanding of astronomy, helping us unlock the mysteries of how stars evolve and what their violent deaths mean for the universe. All in all, Betelgeuse, as a massive and dynamic star, is an essential piece of the cosmic puzzle, and its eventual downfall will be one of the most fascinating events in the history of our universe. While Betelgeuse's death is inevitable, it's important to remember that the universe is constantly changing and evolving.